6, 4, nth roots. So this is about how to find nth roots and what they are. So we know how to find squares of things. If I ask you what is 3 squared, it's 9. And I say what's the square root of 9? You go, it's 3. These are inverse operations. Well, the same thing with nth roots. If I ask you what is 2 to the 4th, I expect you know it's 16. If I ask you what the 4th root of 16 is, it's what times itself 4 times get to 16, that would be 2. Because again, these are inverse operations. So some examples up here. X cubed equals 64. So the cube root of 64 equals 4. X to the 4th equals 625. So the 4th root of 625 is 5. Right? That's all it is. X to the 5th is 32. You try and like, what times itself 5 times equals 32? That would be 2. So nth root just means, hey, if I give you the nth root of some number, it's what number times itself n times equals that value. That's all it's saying. Okay, so let's talk about some vocab. That's the little power. You can write that, call that the index. Right, that's a radical sign, duh. And this is a radicand. Right, so the thing inside is called the radicand. That's called an index. We don't use that fancy talk that often, but whatever. Okay, before we start this, I'm going to go down to the bottom, give some space. Powers you should know. So we get to the point where there's powers, we should know some powers of certain values. So like 1 to any power we know is 1, that's not a big deal. 2 squared we show it's 2, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32, and 2 to the 6th is 64. Those are the ones I feel like you should know. You should have those memorized. You can go 2 to the 7th if you want, and 128, but really the ones that are going to be used a lot are like that to the 6. 3 squared is 9, obviously. 3 cubed is 27, and 3 to the 4th is 81. Those, again, you should have memorized. And there's more, keep on going, but those are the ones you should definitely have memorized. All the rest, you should kind of give them to their power, right? So 4 squared is 16, 4 cubed is 64, 5 squared is 25, 5 cubed is 125, 6 squared is 36, 6 cubed is 216. What am I at? 7 squared is 49. 7 cubed is 343. And so on. So like those are the ones you really should have memorized. It's to make your life so much easier, especially for the next probably 2 chapters. You really have to know your powers. 2s are super important because we use them a lot because we can make small numbers. But 3, 4s, 5, 6, 7s, you have to know those basic powers. We know those, it makes your life so much easier for the next about chapter and a half. So let me go back. Remember back when I did a square root of 9 and I said it's 3? That's actually not totally true. Right, there's 2 answers. When you take the square root of a number, you get plus and minus 3. Because negative 3 times negative 3 equals 9. And 3 times 3 equals 9. But to ignore the confusion, and really what we mostly talk about is the positive one. We call that the principal root, the positive value. So when you see me write answers there, we generally write with the principal root in mind. Oh, let's talk about variables before I forget. So that's how we do variables. So remember if I give you the cube root of x, we could rewrite that as x to the 1/3 power. Well, what if that x on the inside has a value already, like if it's cube root of x to the 12th? Then we just rewrite it, x 12 times 1/3, which you can multiply and you get x 12/3, so x to the 4th. If you notice, all that happened was that power got divided by the root. So if I give you something like, what's the 4th root of x to the 20? All you have to do is go, okay, it's x 20 divided by 5, which is x to the 4th. And then what if there's no root there? Like, can I give you w 10? Remember, no root is the same thing as the root of 2. Square root is 2, like you need 2 things to combine. So this is going to be w 10/2, also known as w5. So that's how you do variables. You just rewrite the powers. right? Or you just divide the power by the root. So power divided by the root, right? Because that's the way it works mathematically. So let's go up here. When I do these problems, I kind of separate it. I go, okay, plus and minus the number, and then the square root of y to the 8, because this makes it easier for me. Square root of 100 is 10, so plus and minus 10. And then, again, all I'm going to do is divide the 8 by the root there. There's no power, so it's a 2. 8 divided by 2 is 4, so this is y to the 4th. Over here, again, I'm going to do the exact same thing. I like to do the numbers separately. I mean, you don't have to rewrite it, but in your head, that's the way you do it. To u, that's a v. So that's going to be 7, and there's a negative on the outside, so negative 7. And then again, all you're doing here is dividing each one of them by 2, because there's no root, the root's 2. So 8 divided by 2 is 4, and 12 divided by 2 is 6. So then he goes on with the next one, right? You see this big old thing there? I see a lot of kids like try to do a power of each one, which doesn't work anyway. Just rewrite it. This is a 2. So y minus 6, 8, also 1/2 power. Well, you multiply these, which is just 8 divided by 2, so it's y minus 6 to the 4th power. And that's how I do it. So some more practice. Next one here, again, we're going to separate these. In your head, you don't have to rewrite it, but in your head. I rewrite it because I teach. So, 4 root of 16 is one of the ones I said you have to start getting used to memorizing those. 4 root of 16 is 2. Then here, 16 divided by 4 is g4. 24, if you can read that, divided by 4 is h to the 6. Right here, square root of negative 16. We could do that. We're not scared anymore. We've learned how to do that. That is 4i. Again, we're just doing the principal root, so no plus and minus. So just put. I'm not solving it, so we just generally want the principal root. If you're solving, you want the plus and minus. Here, you're going to divide it by the root here, which is 2. So 4 divided by 2 is 2. 4i y squared. And then here, just like the one I started off with, we're just going to go 12 divided by 3, so I get a4. Now, here's an extra credit opportunity. So there's a special thing when we take the square root, when we go from even roots, even power, to odd root. Odd power, I should say. So when you go even to odd. In that special case, technically you're supposed to put absolute values around things, around your answer. So let me give you a quick example. The 4th root of x to the 12. You're going to get x 12 divided by 4. You get x cubed. Right? So you went from even root, even power, to an odd value. This one I'm supposed to put absolute value. Why? Because you can't have a negative root. Right? When you take an even roots have to be positive. Right? Even roots have to be positive. Otherwise you get an I. I could take a square root of I could take a cube root of a negative number, that's fine. Cube root of negative 8, negative 2. But I can't take the square root of negative 4, because that's 2i. And that's why we have to put the absolute value. You're supposed to put absolute value if you go from even to odd. Because if it's even, that means it has to be positive, but then if you get an odd value, it could easily be negative. Negative 2 cubed is negative 8. So you put an absolute value there. Again, it doesn't really matter when we talk about principal root, so the book kind of ignores it after this lesson, after this particular moment. But technically, when you go from even root, even power to an odd power, you're supposed to put absolute value there because you have to make sure it's positive, so otherwise you get an I. That's it. So if you do it, I give you extra credit. If you don't, I really don't care because most of the time we care about principal root anyway. Anyway, to get back to this problem, we're going to separate it, right? Cube root of 27 is 3. 18 divided by 3 is B6. And then C12 divided by 3 is C4. Again, no absolute values because, first of all, it's an odd root, so I don't care already. Right? It's only even to odd. Even to odd is where I care. So the next one, again, we're going to separate in our head. The 6th root of 64, that's 2. Gotta get better with those. 18 divided by 6 is 3. 2y plus 3. And this one would be when even root, even power to odd. So this one I have to put an absolute value here. Make sure that thing's not negative. And if you do that, I give you plus a little extra credit. Next one, square root of negative 64. So that can be 8i, right? Square root of 64 is 8i. I can't take a square root of a negative. And then remember it's like a 2. So that becomes 8 divided by 2 is y4. And then 6 divided by 2 is z3. And much like how negative 64 had an I, the z3 would have the same thing. So that's when I put absolute value around z3. Because it goes even to odd. Again, if you do that, I give you a little extra credit. But it's not the biggest deal in the world because most of the time we just focus on the principal root anyway. Anyway, almost done. Let's about to use this in our calculator. Let's bring out our calculators. Oops. They want to approximate 3 digits, so they want to do negative square root of 76. This is how you put it. So we're going to put negative. Now square root, you could second square root right here, and then 76. Negative 8.78. Approximately. Almost right the negative. Now that's easy. I think everybody knows how to do that. And this one I want to show you. This is why we're here. The fifth root of negative 43. Now again, I could take a square root of a negative there because it's fifth root, so it actually works. How do you get the fifth root though? You don't see it on here. You have to go to math. And if you go down to the number 5, that lets you put any power you want. So you put that there. That lets you put any power you want. Let's change the answer to 5. Then negative 43. And you get negative 2.122. Now that's one way to do it. I'm going to show you another way to do it also. Another way you can do is you can rewrite this. That's the same thing as saying negative 43 to the 1/5 power. So that's another way you can write it, put it in your calculator. So if you go parentheses, hit the path of parentheses, negative 43 to the 1/5 power, give you the exact same answer. So 2 ways you can do it in your calculator. Okay, let's finish this up. One last one. An application problem wants to increase the size of the boxes it uses to ship orders. The new volume n is equal to the old volume v times the scale factor cubed. So they're saying the new volume is n, and the old volume is v, and the scale factor is f cubed. You can see the formula right there. So n equals v times f cubed. Now keep in mind what everything means. So this is new. This is old volume. This is old with 1L. Scale factor. It's an S. What is the scale factor if the old volume is 0.8 cubic centimeters? So that's this, 0.8. And the new volume is 21.6 cubic centimeters. So the new one is 21.6. They want to know what the scale factor is. So again, application problem, we could use our calculator. We're going to divide by 0.8. Just solve for f. 21.6 divided by 0.8. These real world problems in the real world ugliness of decimals. And I get 27. That worked out nice. I take back what I just said. 27 equals f cubed, and then you cube root it, and the scale factor is 3. So there we go. That's the lesson.